Hello, and welcome to Chapter 20 homework. So, the conceptual questions. Conceptual question number 2. Car batteries are rated in ampere hours. To what physical quantity do ampere hours correspond? There's a lot of this stuff in electronics that we need to kind of plow through. So, kilowatt hours, ampere hours, that kind of thing. What does that mean? And it turns out that ampere hours, amperes, remember, are coulombs per second. Hours is time, which we don't have to spend too much effort to figure out that that's 3,600 seconds. So an ampere hour is coulombs per second times seconds. So seconds we cancel out, we get coulombs. So ampere hours is really just a measure of current, charge in coulombs. Not current, charge in coulombs. If aluminum and copper wires of the same length have the same resistance, which has the larger diameter and why? I need an eraser. I haven't left you entirely. So, resistance equals resistivity times length over area. We want to figure out area is proportional to diameter, so we can just go ahead and figure out this relationship to area. I'll multiply both sides by area. R equals rho times L. Area equals rho L divided by R. They have the same length. They have the same resistance. So the only distinction, the one with the larger resistivity will have the larger diameter because it has the larger area. So the resistivity values, I would look those up. Resistivity of aluminum is 2.82 times 10 to the negative 8th ohm meters. Resistivity of copper is 1.72 times 10 to the negative 8th ohm meters. So because aluminum has a larger resistivity, it has to have a larger diameter to have the same resistance for the same length of wire and everything else, because copper isn't as good a conductor as copper is. So if it has the same overall resistance as a copper wire and it has the same length, then it must also have a greater area, because that would tend to reduce the resistance. Okie dokie. Give an example of a use of AC power other than in a household. Similarly, give an example of the use of DC power other than that supplied by batteries. Electrical generators, I mean, does that count as not being in a household? So if you have a generator to run electricity outside of your house when the storm comes, or if you're off camping somewhere and you have a gasoline-powered generator, that will be producing alternating current because it's going to work by a process that we'll discuss later on of a cycling magnet inside a coil, and that will produce AC power. DC power, other than that supplied by batteries, I might go with lightning. There's a whole lot of power in a direct current kind of way. I'm sure there's a ton of other examples, but those are two that pop into my mind right away. Those are the conceptual questions. Now it's time for problems and exercises.